In this video is a section continue from a previous video, that the derivation of formula for charge on an RC series circuit. Alright, which in the previous video we have learning this formula, which is the dq dt, right? dq dt plus with 1 over CR qt, right, equals to E over R. Right, through by using first order linear differential equation and the knowledge of first order linear differential equation and the integrating factor, we have finally reaching that the formula for charge according this to the RC circuit will be EC, the electromotive force and the capacitance, by 1 minus E negative 1 over CRT. Right. This derivation is very important. Alright, you should derive the formula before you solving this question. Alright, please refer to the video for the derivation of this formula. Right. So now I'm not going to show you the derivation. So I just show you what is the application here. For example, you look at this question. They were given you the electromotive force, which is actually the E, is applied to an RC circuit. Is 100 volt. Right. Means that you know that this is your 100 volt. Right, 100 volt, and your capacitance, this is your capacitance. Capacitance refer to C, and electromotive force refer to E. All this is a constant. So the capacitance here will be 10 to the power of negative 4, right? Negative 4, and 1 minus with E, negative 1 over CR. And what is your resistor? Resistor is resistance, which is also a constant. A resistance with 200 ohm. So I know that this will be capacitance is 10 to the power of negative 4 multiplied with 200 multiplied with time. Right. So then after I doing all the derivation, please do that derivation. Alright. Do that derivation for this question, followed by using this formula. Alright. So then you know that Q, the charge. So according here, the charge is using Q, the small letter Q. So I'm using small letter Q, which is equals to 100 times with 10 to the power of negative 4, which is 0.01. Alright, 0.01 for this, multiply, and followed by 1 minus with E, negative 1 over 10 to the power of negative 4 times with 200, which were giving you negative. This whole thing will become 50, right? Negative 50t, right? So this is the formula, right? This is the formula for the charge of this on the capacitor, right? So means that it's Q charge on the capacitor at time t. So given that Q0 is 0, so that doesn't matter, because just now when we derive this, we already know that when time 0, the charge will be 0, right? So now they want to determine the charge as time approaching infinity. Means that as time as t approaching infinity, so actually the limits of the Q, right, the charge here. So the charge as t approaching infinity means limit of the charge as t approaching infinity is the same as t approaching infinity. So 0.01, 1 minus with E negative 50t, right? So as t approaching infinity, this whole thing will nearly 0, right? As I explained in the previous video, this is actually 1 over exponent to the 50t, right? As t approaching infinity, this whole thing become infinity. A number divided by infinity, which is a very big number, is nearly 0, okay? Which will be, you're reaching 0.01 coulomb, right? Coulomb. So this is a unit for charge at that capacitor when the time t approaching infinity. And we also can using this formula when the time t is 1 second, right? 1 second, or t is 0.003 second, alright? So you can using this formula and finding the charge at that time, right? But usually this formula is using to determine the limiting charge of the capacitor. Alright, that's all for this video. Hope before you're watching this video, you're watching the derivation of the formula for this video. Alright, see you.